I will kick it off. My name is Martin Burrows. I'm the host. I work as business area manager for Sweden within the AEC business. We're very happy to be working with Bimfire Software since a year back, or a bit less than a year back. Our role is that we are the exclusive actually reseller of the Bimfire tools, and we also have, of course, knowledge in the product and can help customers out in training, different training, and also consultancy to get up and running as soon as possible with the software. My role as a moderator today is to introduce Niklas, and Niklas, he's from Bimfire Software, and Niklas, you are a trained building engineer. You work as a Tengbung as a model manager there. I'm sure you can say a few words more about yourself here in a minute or half a minute. And also, I'm keeping charge of timekeeping, and also if there's some troubleshooting or if there's something that comes up in the chat, I will make sure that Niklas gets to know what's going on in the chat if there are any questions there. So with that said, I'll swap over to you there, Niklas, and also I'm as the timekeeper, I will make sure to let you know 5 minutes before we need to finish, which is approximately a bit less than 20 minutes from now. But here you go, Niklas, it's all yours.
Perfect. I will share my screen, and it looks like I'm sharing. Perfect. So I'm going to talk about getting started with Bimfire requirements within different construction projects. Quite short about me. I'm the head of digital design at Bimfire Software. I've been working professionally with different BIM software since early 2010, so almost 11 years. As Martin said, I have been working at the architectural firm, and then went to an Autodesk reseller, having all the consultant sales team and being a teacher for approximately 6 years before starting at Bimfire Software and starting develop among other software, but especially this tool that I'm going to talk about, and talk about the journey we had developing this and the mindset we were focusing on when we did create it from scratch. So the background, why did we create this? The fire engineer started going digital approximately 10 years ago, because they then printed, and still do in some cases, print the actual sheets onto paper and draw on it, redline upon it, and scan it back into a PDF document and send it back by email. The transformation they did approximately 10 years ago, even closer as 5 years ago in some companies, they started actually draw on the PDF itself using different PDF readers. And this is a workflow that basically everyone that is adding requirements onto other disciplines, components or models or drawings work. And all the other stakeholders are actually dependent on these drawings, because they are mandatory to have and completed before the building construction is complete. So when we did want to change this, it was quite easy for them to go from a printed sheet to redlining on PDF, because it was basically the same workflow, meaning just redline above a sheet. So what we wanted to do is actually have a low threshold, because we don't want the fire engineer to combat with us, moving from PDF into a model. So we wanted to have a recognition factor. We wanted the fire engineer to think, this is kind of how I work right now, but in a slightly different way. We wanted the same work process as before. We don't want to change the entire way they are working, because then once again, they will combat us trying to change that industry, this industry. And most importantly, that the delivery that we are delivering right now, the PDFs, must look the same. We can't change how the symbol works, even though we could think of better ways of handling the information. We don't want to change it too much because it should have a recognition factor going back to that. So that was the idea we had working with the fire safety engineer. But they are not the only persons in this process. As I mentioned, everyone is dependent on the fire safety engineer. So what we also wanted, we wanted to take a look at the stakeholders, the architects, the electric engineer, the MEP, the mechanical engineer. How are they working? So we don't want to disturb their work process, because if we're telling the architect or the MEP engineer, you need to change your work process to make it work for us, then the receiver of the information will also be someone who will combat us going into the model. This is, I would say, one of the main factors and main problem with energy simulations, for instance, meaning that the model that we're working with must change so much, so it becomes a hassle for the architect to work with. And another question that the stakeholders always have, so we want to go into their workflow. We don't want them to change anything, but we also want to quality assure them that we aren't going into their model, going into their data, their sheets, and changing something that they have no control over. So we want them to think that we get the same, but more. So with all these 3 different pillars, we started to create different kind of software. And the first software that we have is the Bimfire tools. And what is more from the same? First of all, the first I want to talk about is that there is, of course, more of this, but that is what I like to call this fake word that we figure out was the direct values. So the direct value that we can see is, first of all, the fire resistance for doors, walls, and windows. This is actually what everyone uses on their sheets, their floor plans. We can see the redlining on the walls, explaining with the colors and the line styles what kind of fire resistant they are on this wall. Or we can use tags on the doors explaining what kind of fire resistance on that door. Should this have an automatic door shutter? Should this have smoke resistance? And how, of course, how long this door should last in case of a fire. These are the main and simple information that most architects actually manually enters, because this is going to be used on their sheets. So instead of skipping the middleman, sending the PDF basically, and having the architect entering this data themselves, why not do it as a fire engineer? So that was one of the first direct values that we had. The second we started thinking is a huge problem as working as a fire engineer is the detailed design. As I said, and you know, the engineer is actually usually working on other people's drawings. So we are stuck, so to say, with those sheets that are sent to the fire engineer and only them. And it's usually floor plans. And of course, a few critical sections. But having an engineer creating their own model, fire safety engineer creating their own model, we can actually start to add more drawings explaining what we mean with the requirements that we have. So this is a traditional staircase that we have, and we want to have a fire resistance under the staircase. And it's quite hard, as most people understand, to showcase this in a floor plan. So just by being able now to do sections and explaining under this staircase, there should be a fire resistance under it, because there is a fire compartmentation under the stairs. And this is usually sent in all the projects, I would say, are sent as a Word document or a PDF in pure text in the fire documentation, saying the stairs in staircase 1, 2, and 3, A, B, C, those need to be fire protected. Now we can actually show it with more detailed design. Another thing, just having a fire safety model, because the important thing here is we want to actually create our own model that can be used. And what we can use our model as a result, basically as having a result, creating a 3D fire safety model, is that we can have what I have mentioned here as a clash detection. But it's not traditional clash detection, because when we're talking about clash detection, it's to see if do our ducts collide with some structural beams, some structural framings. Do we need to have the structural engineer had created a hole for this door in this structural wall? This is not the kind of clash detection that I'm talking about. But we can use the clash detection as a mechanical engineer, just to use or to find all the penetrations that we have through a fire compartmentation. Because around this is a duct going through several compartmentation, as in a residential building, not really a real project, but they can, with a click of a button, do a clash detection between their mechanical model and the fire safety model to find where do we need to put a fire seal or a damper, for that matter. We can do quite easily figure out, do a checks, have we put in dampers in all the penetrations or close to those penetrations? What kind of material are we using on those pipes? Do we have plastic pipes going through this compartmentation? This can be easily found just having a 3D model as a fire safety engineer. So those are the kind of the indirect values that we get just having a model. Then, the direct values. Then we have those indirect communication. And this is a Swedish door specification sheet. So after we added some, of course, a fire resistance on those doors or windows, we can actually start adding even more information. What's the door fitting? Does this door need to have a door magnet, re-entering, accessibility requirements? Everything that actually the fire engineer and the security engineer can add information that is used on the door specification sheet, which as well the architect is manually entering, using straight in the BIM software or in a third party, but they manually entered the information from the fire safety engineer that is sent to a third party, the person who actually going to need to read this information and buy the correct component to this store. So here we can actually add more information as indirect to a third party information as the door specification sheet. We can start using the so-called technical installation. Most of you might recognize the green, which means that this is an evacuation route. And by having those color schemes or hatches as we used before, because this is a component, a 3D component saying that this is an evacuation route, we can quite easily check the electrical model to see every space, every area that has cables within the evacuation routes need to be fire resistant, because if there's a fire, they need to be still working for at least 30 minutes. And we can quite easily find this because we are working in a model. And this is something as well, the indirect values that they don't do more than they read on the construction site. They have the fire documentation, they have the electrical drawings, and they need to figure this out themselves. And of course, as you can imagine, this causes a lot of errors within the models. But we can as well, still talking about the electrical model, we can actually check our model by checking. As a fire engineer, we require the different signage to have in our model and what kind of signage it should be. And we can check, has the electrical engineer added those signage in their model, at least on their drawings. We can't know for sure on site yet, but we can at least check that we can quality assure the documentation with some kind of clash detection to see if in these rooms that we have required signage, has the electrical engineer put a sign there as well. Instead of the workflow that most engineers do today, is they have the electrical PDF file open in one screen, and they have the fire sheet on the other screen, and they check sign, in this case, a signage. We have required a sign, and this has required a signage. By starting having a 3D model that we are being able to use our 3D components, being able with Bimfire tools, sending information to other stakeholders directly to that component that that should have these requirements to be used in specification sheets on floor plans. Having those 3D objects being able to check, has the other disciplines actually put in those kind of components. That's all possible by working in a 3D object and using tools like Bimfire tools to have a complete ecosystem of information. That was actually what I was just going to talk about and show. And Martin, do we have any questions?
Yes, one is from Kenneth. Is this integrated to a BIM Door Manager? Question is.
Not yes and no. The BIM Door Manager reads information from the architect model. So it's possible to send the information to the architect model through a Bimfire tools and then read it to the door manager in BIMI.
Second question is that okay, for a new customer, how long time does it take to get started? What's the time frame and what's the main obstacles as such?
Okay, so our idea with the low threshold, we wanted the only barrier to be you need to learn how to use Revit. That was our lowest threshold. So if you know Revit from school, or you a new student who knows Revit, they can on a day, not even a day and half a day, you can learn Bimfire tools itself and being able to send this information. So the main threshold is Revit. And what we have been working with our customers, it's somewhere around, now with this, everything is remote, but we have around, if I remember correctly, around 30 hours training from start till end. That's included so-called floor walking or sessions with a real project.
Excellent. Then also for the rest of you guys in the meeting, if there are any of you that have questions right now, please type them into the chat. I'll keep track of them. I've got one more question. We've spoken mainly about the fire engineers here, but are there any other user categories that have value, both from the tool as such, but maybe also from the information that the tool provides?
Right now, we have focused on fire engineers, but the main idea behind this could be used by a security consultant or acoustic. It would be the same workflow with the same, not the same information, but the same components sending the information to the same components in the other stakeholders' models. If it would be a construction engineer model or an architect model or an MEP model. But we have not yet any templates with, let's say, lineage, but even though it's a 3D object, a lineage for acoustic, for instance, or not really all the symbols for security, because there's a lot of different. Not yet, but hopefully soon we will as well add them as well.
Excellent. Thank you very much. There are no further questions, at least not in the chat. So what we'll do is we will close this session now, like 2 minutes advance of time. The next keynote starts in 10 minutes from now, 15:47. Timo, he tells me, check the Q&A. Thank you very much, Timo. There might be questions in the Q&A as well, yes. And then the question there is, which country standards currently are supported out of the box?
Right now, those countries we are having: Sweden, UK, Norway, United Arab Emirates, and coming soon, Finnish.
And then taking that Timo is from Finland, he might wonder how soon is soon.
Before the summer, I suppose. We're working on it.
Excellent. Then yeah, Timo, he has some more responses there. Excellent. So then I don't have any further comments here. The next session starts in 8 or 9 minutes from now. I would encourage you to go to the networking session if you have a few minutes before then. I'll stay in here, see if there are any other questions that pop up together with Niklas. But apart from that, I'll thank everyone who is attending, and also Niklas for the good presentation. Thank you very much, guys.
Thank you.
Bye.